Very good morning. Today I am going to take the GATE coaching for artificial intelligence. I am J. Muthukumar, assistant professor working as assistant professor in artificial intelligence and data science department. Today my topic, what I am going to discuss in artificial intelligence, search techniques. So the important topic of search technique is informed search and uninformed search. So what is informed search? Informed search is where the parameters are known for the thing you are going to search. Okay, so that is called informed search. So you know the destination where to get the data. So the three types of informed search are heuristic search, best first or greedy search, and A-star search. So the most probably the GATE questions will come from these three topics. One is heuristic search, and then best first, or otherwise it is called as greedy search, and third one is A-star tree search. So first one we will see about the heuristic search. Heuristic search is nothing but based upon the heuristic parameter h of n. You will going to start the initial stage from the initial state to the goal state. So the process it will be starting from solving the method using the goal state as well as the initial state. That is the logic of heuristic search. So the parameter will be used is h of n. So this is a technique widely used in informed method in AI. Okay. So next one is best first search. It is otherwise called as greedy search. The best first search method, we have two types. One is breadth first search, another is depth first search. BFS and DFS, we can call it as two types. So this is a search algorithm which is properly used with the concept of priority queue. The queue is nothing but first in first out. The logic is first what data you are entering into the queue, that will be popped out. So that is called queue. Based upon that queue, you will be using the priority concept. Priority concept means the first thing which is coming for the process, that will be popped out. So that is the logic. So you will be using the two methods. One is breadth first search and another is depth first search. Breadth first search is you will be searching with the level wise. Level 0, level 1, level 2, level 3, like that you will be searching. So that is breadth first search. And depth first search is based upon the tree hierarchy. You will be searching the one side from the top to the bottom. Okay, so that is called depth first search. We will be using both the concept in BFS, which is widely used in one of the informed search technique. Okay, and it also used to find the shortest path. So whenever you are using this technique, you have to find the shortest route to the destination. So starting from the source, you have to go to the bottom. Next one is here comes the A-star search algorithm or AO star. Both are used in the informed method. Here in this thing we have a different technique where we will be using the heuristic function with the initial state and the goal state. Okay, heuristic function will be using h of n. The summation of heuristic function h of n equal to f of n plus g of n. You will be using this logic in A-star algorithm. Here you will be using the uniform cost search method also, which is also a part of your BFS and DFS also will come in the heuristic search method. And the A-star method locates the shortest route. So it also combines the logic of finding the shortest route from the source to the destination. Here I already told g of n plus h of n, the summation that will be used in getting the widely used result. This is called A-star algorithm. It is a combination of UCS, that is uniform cost search, and greedy best first search. Okay, so it combines both the techniques. So it is also one of the informed search technique which is widely used. Okay, the results are more accurate when you compare with the BFS and heuristic search. These results we use in the A-star will be more compact as well as more optimal solution. Next comes the uninformed search method. So we have seen the three types of method which is used in informed search. Now we will see the uninformed search technique, which is also called blind search. Why it is called blind search means we don't know the parameters, or we don't know what is the process we are going to start, or how you are going to proceed from the initial state to the goal state. So that is called the uninformed search technique. So without any knowledge or without any specific parameters, we will do the searching process. That is called uninformed search. So we have four categories of uninformed search. One is depth first search, what is called DFS. It is most widely used uninformed method. Next one is UCS, Uniform Cost Search Method. And next one is depth limited search, where your limitation of search will be only constrained to the number of nodes used in the route. Okay, so that is depth limited search. Next one is IDS, iterative deepening depth first search. Okay, so this is a specific method based upon the DFS. You will be using this technique. So these are the four important category of uninformed search, where you can get the questions for GATE subject, GATE exam based upon these four uninformed search techniques. The first one, the first category we will see about the depth first search. Depth first search, I already told you the logic. The logic is first you will search from the top to the bottom. So one side you will be searching till the end of the node. End of the node means that is the last point you will be searching. So from the level 0 to level 4. Suppose if you are having a root node or root architecture, you will be searching from the first thing to the last stage one-sided. That is called depth. Depth means level 0 to level 1, level 2, level 3, level 4, up to 4 levels you will be searching. So it also mainly use the concept of data structures, trees and graphs. Trees and graphs. Already I told you about the trees. Tree structure is the main thing of DFS, where you will be having the root node, child node, parent node. So this is called the root node, and this is the left child, and this is right child. So the same logic, it will be keep on searching. This is level 0. This is level 1. Like that you will be having the various categories. So it will be searching only to the one side. This is called depth. So this is called depth. So this is called DFS. So depth first search means it will go on one side. So if the left child is greater means it will go to the left side. If right child is greater means it will keep on searching to the right side until to the destination. Next is uniform cost method. This is very cost effective search, where you will be using the cost effective techniques to reduce the cost, finding the route, finding the optimal solution. Okay. So it is also based on the graph method. It will be most cost effective. It will also start from the root node and expands the node in order to find the minimal cumulative cost. This is called uniform cost search method. Next is depth limited. Depth limited, like so it also works like a DFS, where the only constraint is you will be having infinite path. It resolves the infinite path, and also it is a graph with a large number of nodes. Your nodes or your tree structure will be large, so that you can find the limitations. Okay, so nodes at the depth limit are considered for further successor. Okay, so that is if you keep on increasing your root thing, it will be used. So this is called depth limited node. It is mainly used based upon the concept of DFS. Okay, so it also resolves the issues of infinite path. So if you have infinite loops or infinite path in the root structure, that also will be resolved. Next is iterative deepening method. It is uninformed search that combine the complete BFS. BFS is birth first search. Already I told you, birth first search is nothing but the level wise searching. So if you have a root structure, root node, left child, right child, again left child, right child. So you will be having various levels. Based upon the level wise searching is birth first search. So it also uses the concept of birth first search, and also it increases the memory efficiency. Okay, this approach mainly avoids infinite length. So it also avoids the problem of infinite path which is faced in the previous category. Okay, it also searches the desired path. It returns the root node to explore the different types. Okay, so this is called iterative deepening method. Iterative deepening method is nothing but it is also based upon the DFS method. The only thing is it is able to solve the infinite path of the thing and also find the root node, which is essential to find the optimal solution of the search. So it also reduces the time complexity and space complexity of the method. Now we will get into the MCQs, which is used for the GATE. thing. Okay, so as A is considered, this is the first set we are going to face the A gate subject. In this, based upon the search techniques, both we have discussed about the informed search and uninformed search. We have some MCQs. Okay, so first one we will see about the first MCQ. First question, listen carefully. Which search algorithm is guaranteed to find the shortest path in a weighted graph with a non-negative edge? Non-negative edge means it is a positive one. So non-negative edge weights. So based upon this query, you have given 4 options: birth first search, depth first search, and Digitras algorithm and A star. So based upon this thing, birth first search, it is not guaranteed to the shortest path. So we can avoid this one. Next one is depth first search, and the third one is Digitras algorithm. So the option is Digitras algorithm, which is used to find the non-negative edge shortest path. So the option is Digitras algorithm. Okay. So this is the first option. Second one. Informed search algorithm differ from uninformed search algorithm in what way? So the question is, what is the difference between informed search and uninformed search? Here you can see the 4 options. The first option is use heuristic information to guide the search, explore all the possible paths equally. We require complete knowledge of the search, are not suitable for problems logically. So in this case, the option is first one, use heuristic information to guide the search. So the major difference between the two things is, you have to use a heuristic function h of n that will be used to find the optimal solution or to guide the search. Okay. Next one, which search algorithm is often used for solving the problems limited depth but a large branching factors? In this case, you will be having the 4 options: depth first search, birth first search, iterative deepening depth first search, uniform passage. When you consider factor large branching factors, automatically the iterative deepening method will go for this one. So the option is C, IDS. Next one, what is the main drawback of depth first search? So for this thing, it requires large amount of memory. It does not require guaranteed finding the optimal solution. It is not suitable for problems with a large branching factor. It does not work with graphs containing circle. So the option is B. It does not guarantee the finding the optimal solution. So that is the major drawback of depth first search, because we are not able to find the optimal solution using the DFS. Which heuristic function is admissible for the A star search algorithm? The option is A equal to h of n equal to 0 for all states n, B equal to h of n equal to estimated cost from the current state to the goal state, C equal to h of n equal to maximum edge cost in the search space, D equal to h of n equal to number of steps taken from the initial state to the current state. So the option is B. H of n equal to estimated cost from the current state to the goal state. That is the logic which is used in heuristic function, which is used in the heuristic function of A star algorithm. Next, 6th question. Which search algorithm combines the features of birth first search and depth first search? The option are A equal to uniform cost search, B equal to greedy base first search, C equal to depth limited search, and D equal to iterative deepening depth first search. For this, the option is greedy base first search. Seventh one, Which search algorithm guarantees finding the optimal solution for a problem with a non-negative edge? So here I have to find the search algorithm which we use to find the optimal solution. So based upon this options, A equal to A star search, B equal to birth first search, C equal to depth first search, D equal to uniform cause search. So we can go for the option D, uniform cause search method, which is used to find the optimal solution with a non-negative edge. Eighth one, in eighth one, in A star search, the evaluation function f of n is defined as f of n equal to g of n plus h of n, where g of n is the cost of the path from the start state to node n, and h of n is the estimated cost from the node n to the goal state. B equal to f of n equal to g of n, where h of n is the estimated cost from the current state to the goal state. Next one is f of n equal to g of n, where g of n is the cost of the path from the start to the end node. Last option is D, f of n equal to 0, as A star search does not use an evaluation function. Based upon the four options, the given option is A star search, the evaluation function f of n. So already we discussed in the A star search, f of n equal to g of n plus h of n is the correct answer, where we have the cost of the path from the start node to the node n, and h of n is the estimated cost from the node n to the goal state. So which search algorithm, ninth question, which search algorithm is suitable for solving the problems with a large branching factor limited memory? So whenever the question is asked large branching factor and also the limited memory size means defaultly it will go to the BFS. BFS is one technique where you will have the limiting memory size as well as the large branching factors. Okay. So the options given are A equal to birth first search, B equal to depth first search, C equal to iterative deepening depth first search, and B equal to bidirectional search. So the option is A. Birth first search is a search algorithm which is mainly suited with a large branching factor and the limited memory size. And the last 10th question is, which search algorithm used when the depth of the search space is not known? When it doesn't know the depth of search, it is defaultly understood that it is an uninformed search method. So based upon this four category, first one is depth first search, and birth first search, iterative deepening depth first search, and uniform cause search. Since uniform cause search does not will come because it is a cost effective method, but when you take the space, iterative deepening depth first search is the right answer for the question given. Depth of the search space is not known. So the option C is the right answer for this method. Thank you.